So my dear children, this is a heavy rock which I have with me right now. By using the principle related to the lever, I'm going to move it to a different location. In our normal day-to-day life activities, in order to remove like this kind of a heavy object, we use the instrument called crowbar, right? So the crowbar is somewhat related to this lever incident, which I'm going to apply over here. So here, let's imagine that this is the crowbar. Now, I'm going to place the crowbar like this. Then this is the fulcrum. So I'm going to apply the fulcrum somewhat near to the load, like this. Now at the other side, I'm going to see by applying very less amount of force, I can lift it without any trouble. See, keep it like this. Keep the rotating one or the fulcrum like this. Then by applying very simple force, I can move it. See. Then once again, like this, I can move it. Okay. So it's very simple, my dear children. As you can see, just by using one finger at the other end, I can move this thing without any trouble. So if I'm going to lift it like this, it's very heavy, right? So I won't be able to take it like this. However, if I'm going to keep it like this and use the knowledge of a lever, then like by using just one finger, I will be able to move this thing without any trouble, as you can see, right? So like this, see, just one finger I can move it without any trouble. It's because that, right? It's because that the lever is going to make our work easy. Okay, so the action of a simple lever can be demonstrated by using this activity then. So now let's head on to the classroom once more to observe the other things related to the lesson. So my dear children, here we are going to investigate the application of inclined plane. So here I have with me a wooden block, some kind of a weight. I'm going to first of all measure the weight of the wooden block by using the spring balance. So it's equal to 3.2 Newton. 3.2 Newton. Okay. So not here the weight of the object is 3.2 Newton, my dear children. You can clearly observe from here. It's around 3.2. So when I'm going to lift it from the ground level to this kind of a position, I have to apply around 3 Newton and I'm going to place it over here like this. So by application of 3.2 Newton, I will be able to take this wooden block and keep it over here. So to do that, I need to apply 3.2 Newtons. Now what I'm going to do is, I'm going to keep it on this inclined plane. And now I'm going to, right, what I'm going to do is, I'm going to apply a certain force and I'm going to move it or drag it along the inclined plane. Let's see how much is the force now acting. So when I'm going to drag it upward, you can observe the force which is applied is around 1.5 Newton. Right? It's around 1.5 Newton. Once again, we'll see. When I'm going to drag it upward along the inclined plane, with a minimum force, I can drag it along the inclined plane like this. See? So by application of 1.5 Newton, right, I can drag the wooden block to the top of the inclined plane without any trouble. But if I'm going to take it like this, then I need to apply 3.2, around 3.2 Newton of a force. So my dear children, that means by using the inclined plane, we can minimize the effort. We can, by using or by application of minimum effort, we can do the work that we need. So this is another example where inclined plane is useful. if a circular object needed to be placed from here to here, you can keep it over an inclined plane like this. We'll imagine that it is a barrel. So you can roll the barrel like this by using 2 or more people. So without any trouble, with ease, we can roll it. So these inclined planes are used most of the times in order to transport something to the top, okay, to a topper position. I mean, like from ground level to a higher position. To transport substances or to transport materials, we use these inclined planes. So this is the application of inclined planes, my dear children. Right then. So let's head on to the classroom once more to observe the other contents in the lesson. So my dear children, within this activity, we'll be lifting off a certain object by using the pulley over here. So these pulleys are used more often to make our work easy. This is also considered as a simple machine. When drawing water from a well, most of the times we use these pulleys. By using pulleys, we can easily lift off an object, right, by minimum amount of force. So now I'm about to demonstrate how to use this pulley to lift off a certain weight over here. So you'll be needing a certain thread or else a bit of a rope. Then you have to keep it over here, right, at the small bit of an empty space located here at the pulley. Now I'm going to just apply a certain force and lift it. See, very easily it is coming up. Observe. See. With ease we can do the work without any trouble. So we use these pulleys to make our works easy in our day-to-day life. When taking something upward without any trouble or with ease, we can use the pulley to lift a certain thing upward, my dear children. Most of the times these pulleys are used in lifts, right, weightlifters. Okay. Right then. So my dear children, this is the next type of simple machine, which is the pulley. Now once again, let's head on to the classroom to observe other contents in the lesson. So my dear children, here I have with me this instrument. This instrument is called as the screwdriver. We use this screwdriver in order to remove nails, screw nails. So as you can see, the top of the screwdriver is having a greater diameter than the axle which is over here. So this is a good example for a wheel and axle. So what you have to do is, now at the end of the axle, there are certain kinds of cuts, and over the screw nail also there are several cuts on the surface. So you have to insert the screwdriver like this to the cuts, and now by applying force you need to rotate it. So by applying very simple force, we can rotate and take the iron nail, we can take the screw nail out. See, very simple. So this can even be used to fix the screw nails onto a certain surface like this. Okay. So what you have to do over there, you have to keep it and rotate to the other direction. Like this, you can rotate it. Then by that way, it will go to the, alright, go through the block like this. So with ease, we can do the work without any trouble, as you can see right now. But if I am going to turn it by using my fingers, I won't be able to take it up, or I won't be able to move it. However, if I am going to use the screwdriver, then I can move the screw nail without any issue at all. See, by applying a very less amount of force, I can turn it. Now, see, I won't be able to rotate by using my fingers right now. However, when using the screwdriver, I can turn it without any trouble, and I can remove the nail quite easy. So this is a good example for the wheel and axle, my dear children. This is the screwdriver, the usage of screwdriver. Right then. So let's head on to the classroom and we'll observe the other contents in the lesson. So my dear children, to demonstrate the action of a lever, I have prepared a system over here. So you can see there is a wooden bar placed upon a small bit of another wooden stake, and I have prepared this system by using two stands. Now there is a sheet, a surface to place the small bit of this wooden stick, and also to place the wooden bar over here. Now at the other end you can observe there is a book, and I have prepared three hooks. This hook is somewhat near to the stick which is over here. This is the second one, somewhat far, and this is the third one which is furthest. Okay, so there is a spring balance, and by using the spring balance, you know that we can measure the amount of force that we need to apply to lift off this book. Okay, so my aim is to check which hook will provide the least amount of force. You know that this book or the weight of the object is not going to change if I'm going to keep it in the same position without changing it, right? So I'm going to place this thing in each and every hook which is over here. Then I'm going to push it down and measure a certain value which is needed to lift off this book. Okay, the value of the force. Okay, so now the spring balance is in the closest one which is near the stick, right? This is the stick which is being placed. Now this one is somewhat near to it. So I'm going to apply a force now, and I'm going to turn this thing down. You know that when I'm turning this thing down, or else when I'm pushing this thing down, this side goes up. So we'll find out which one or which place will produce which place will give out the least amount of force needed to push the book, needed to lift the book down upward. Okay, so in doing that, so we are going to push it downward. Okay, so we'll see which one will do the work with ease. So this is the first hook which is closest to the stick. We'll put a pause and we'll observe whether we can get it done within a minimum force or not. Okay, so I'm going to push it now. You can see the spring is moving downward gradually. So now it's getting lifted gradually. So I'm going to lift it even more. Right. Now you can observe it's around 3.7. 3.7, my dear children. Right. Our reading is 3.7. Observe clearly over here. Right. Then I'm going to move to the next hook, which is somewhat far away from the stick over here. Okay. Now I'm going to once again apply a push downward to lift the book up. As you can see now, with a very less amount of force, I can lift it. Okay, observe the value, my dear children. If you observe it clearly over here, then the value is around 2.3. The value is around 2.3 Newton, my dear children. Earlier it was 3.7 Newton, but now it has been reduced up to 2.3 Newton. Right, 2.3 Newton Then to the furthest one. So 3.7, 2.3. You'll see the third one. Here we go then. Let's apply a push. Observe the value carefully. Observe the value, my dear children, carefully. It's 1.8 now. Earlier it was 2.3. Now it has been reduced up to 1.8. Okay, it has been reduced up to 1.8. So 1.8 Newton is the least amount of force, right? So by that way we can come into a conclusion that, see, when the lever is somewhat, the force that we are going to apply is somewhat near to the rotating place, which is over here, this piece of wood stick. Okay, so when it is somewhat closer to it, we have to apply more amount of forces to lift the book, the same book. However, if it is somewhat further away from the rotating point, which is over here, then we can, we can within a least, or within by applying very less amount of forces, we can lift the book, or we can lift the weight without any trouble, right? So from this activity we can come into a conclusion that, right, when we apply less amount of forces, right, when we apply less amount of forces to a certain point of a lever, but however the point should be somewhat far away from the rotating point of the lever. Okay, so by that way, by applying very least amount of forces, we can lift the vehicle, we can lift the books without any trouble. Okay, so here once again, can you remember, here it's around 3.7, then was reduced up to 2.3, then once again was reduced up to 1.7, 1.8 Newton of forces, right? So that means, my dear children, when we are moving further away from the rotating point of the lever, then we can, by using or by applying least amount of forces, we can lift the objects or weights which are at the other side of the lever. Okay, right then. Now let's head on to the classroom once again to observe the other things contained in the lesson. Right. So my dear children, here you can observe a typical lever. Now levers are used to make our work easy. You know that if you take a machine, you know that machines are going to make our works easy. So these things are very simple machines, my dear children. So this is a simple lever that you can observe over here. Now you know that within an each and every lever, my dear children, there is a certain weight that we need to lift. So this is that weight. So weight is placed at the one end of the lever. Okay, then my dear children, within this certain point over here, you can observe that the lever is going either up or else down. See, so around this point, the lever is going to turn up or down. That means it's going to rotate up and down actually. Now you can see that if I'm going to apply a force over here, then it will lift. In here, actually when I'm applying a force over here, it will going to turn and travel like this way, right? It shows a clockwise rotation. This one shows a clockwise rotation. So actually in a lever, what happens is, when applying forces, it will tend to rotate, my dear children. Okay, so here you can observe the rotating point. This is the rotating point, my dear children. So we have fixed the bar over here. So within this or around this point, the lever tends to rotate. And this is the place where we are going to apply force to lift the weight placed at the other end. Okay, at this end we are going to apply the force. Okay, so we can observe three main parts in a lever. The first part is this one. This is the place where we apply a certain weight. So this is referred as the load. This is the load. This is the place where the rotation is going to start, the rotating point. So the lever start to rotate, or it will move from this point. This point is referred as the fulcrum. Fulcrum. The place where we apply the force to lift the weight upward is referred as the, this is the one which is referred as the force, right? This is the place where we apply the force in order to lift the weight. Okay, so at the place where we apply the force, the amount of force is referred as the effort. So load, fulcrum and the effort. Load, fulcrum and the effort. So these are the three main parts that we can observe within a lever. So according to the position of the load, fulcrum and the effort, there are several kinds of levers too. However, we'll be studying those things within our next activity. Okay, now let's once again head on to the classroom and we'll observe other things related to these levers. So my dear children, in here I'm going to apply the knowledge of lever in order to open the lid of this tin. So here I have with me a spoon. So what I'm going to do is I'm going to insert this spoon to this cavity, and you know that from here now I'm going to apply a certain force. So you know that it's very difficult to open this tin lid like our fingers, right? We won't be able to open it because I won't be able to apply large amount of force to open this thing. However, by applying this particular object and by the application of very simple force, like by just a single finger, see, I can open it without any trouble. See, just by one finger I have applied the force. However, in the earlier times, right? However, in the earlier time, see, not by our hand, I won't be able to move it even from our hand or even from my hand. However, my dear children, by using this lever technology or by using the principle behind the lever, I can lift this thing without any trouble. See? See? So these levers can be used to do our or can be used to make our works quite easy. Okay. So my dear children, you know that there are different kinds of simple machines. So lever is one of them. So by using these levers, my dear children, like I said, we can make our day-to-day works quite easy. So let's head on to the classroom once more and we'll study the further things related to the lesson. So my dear children, in the earlier activity, we discussed several things regarding the levers. We identified the parts of levers. Now my dear children, we are going to discuss the main orders or classes of levers. So there are several classes of levers or orders. Now first of all, we are going to study about first class or first order of levers. Now within the first order of levers, the rotating point or the fulcrum is at the middle and the load and the effort are at the either sides of the fulcrum or the rotating point. Best examples are forceps and pair of scissors. So I have several forceps with me. You know that we use these forceps in order to grab something, right? So when grabbing this thing, we'll be applying a certain force over here, which is the effort, and to crush or to remove or in order to cut and remove, we can apply the we can place that removing thing or else the other end over here. So when you apply like this, when you keep it like this, by applying very simple force, you know that you can crush and you can cut and remove the load or whatever the thing which is placed over here at the end of the forceps. Okay, so most of the times we use this forceps in order to cut strings, metal strings. Okay, so we apply forces to here, then upon application of forces, it will easily cut and remove, because from the rotating point we are applying a certain force at a greater distance, so the lever will be much efficient. Okay, my dear children, so these are forceps. So this is another forceps that we use to, right, hold test tubes or boiling tubes or sometimes different kinds of chemical substances, right? So this is also belongs to the first order or the first class of levers. This is the rotating point, my dear children. Along the rotating point, right, there are two fulcrum, there are other two components, which is the load and the effort. Okay, so the effort is being applied to here, which is the force I'm going to apply, and the load is placed over here. Then the third and the final one, as you can see here, this is a pair of scissors. So the pair of scissors also the same and identical to the first to these forceps. So here also you can observe the rotating point, which is the fulcrum, right? And from here we apply the effort from the handles, and the blades of the scissors are used to cut a certain material, especially a paper or else a cardboard. So over there we can observe the load, my dear children. So load, fulcrum and the effort. Okay, effort and load are at the two sides. At the middle you can observe the fulcrum, okay, or the rotating point. So these ones are referred as, or these examples are examples for the first order levers. Okay, now let's head on to the classroom and we'll observe the other contents in the lesson. So my dear children, here we are going to observe the second type of levers or the second class of levers. So here within the second class or the second order of levers, I have prepared a prototype of a wheelbarrow. So there are two other wheels over here, but ignore about those things. Okay, you just imagine about the rotating point, which is over here, the rotating wheel, the one single wheel, right? So now these are some objects, some weights. So when I'm going to place the weights like this, these are the ones which are going to behave as the loads. So load is somewhat closer to the rotating point, which is over here. You know that there are handles at this side. So when I'm going to lift the load by applying a force like this, and now I'm going to move it like this, here and there. See? So at the point of the lifting, see, when I'm going to apply the load, when I'm going to apply the effort, and when I'm going to lift it upward like this, right? When I'm going to lift it upward like this, at that point, my dear children, we can observe the second class levers. Not when I'm going to move it like this. Okay, at the point when I'm going to lift it upward like this, at that point we can observe the second class levers, application of second class levers. Now at that point when I'm going to lift it, see, my effort is at this point, this is the load and this is the fulcrum. So fulcrum, load and effort, see, like this, see. So this is the point, the turning point or the fulcrum. This is the force where I'm going to apply the force. This is the place where I'm going to apply the force, which is the effort. And these are the loads. So loads working downward. This is the fulcrum and this is the effort. So when at the point when I'm going to lift it like this, the wheelbarrow acting as a second class lever, fulcrum, load and the effort. Okay, so here the load is somewhat near to the rotating point or to the fulcrum. So by that way we are going to work down, or we are going to move these things quite easily, because from the rotating point to the effort there is a greater distance. That means this lever is quite efficient and we can move it without any trouble. We can lift it without any trouble. This is an example for the second class levers, my dear children, the wheelbarrow. Right then. So remember always at the point of lifting, right, at the point of lifting, here the second class levers are observed. Okay, right. So now let's head on to the classroom and we'll study the further things related to the levers. So my dear children, now we are going to demonstrate the third class or the third type of levers. So the broom and the fishing rod are the examples for the third class levers. First of all, we'll start with the broom. So you know that when we are sweeping the ground, we use the broom. Here we handle the broom like this, and one end, and from the other end we handle it like this. So by applying a force from like middle of the broom, we're going to pull, right, or push like this, pull or push the things on the ground. Okay, so this is the rotating point here. See, from this point it's going to rotate. By applying a force from the middle of the broom, I'm going to rotate it. See, so from here, from this particular end, I can rotate it to either sides. Okay, at the end, at the other end, there is load. See, this is the load. This is the load. Okay, the dust particles. This is the load. So like this, I'm going to apply a certain force from here. So the point of application of force, or the place where the force is being applied, this amount of force is being applied on this place. So on here you can observe the effort. So the turning point is the fulcrum. So in this time, my dear children, the load is at the far end, and my dear children, at the middle you can observe the effort, and at the other side, or at the final end or the far end, you can observe the fulcrum. Okay, so this is the example for a broom. So my dear children, this lever is somewhat inefficient. What is the reason for it? The reason is, now this is the place where we are going to apply the force or the effort. So the effort is somewhat closer to the rotating point, which is the fulcrum. The load is somewhat very far away from the rotating point or the fulcrum. So here in this case, this lever is going to be somewhat inefficient. However, even though it is somewhat inefficient, right, by application of somewhat amount of a force, we can apply, or we can do our work with ease. So this is the third class of the levers. Okay, if you take the fishing rod, so this is a prototype of a fishing rod, my dear children. From here we grab the fishing rod firmly, and this is the place where fish is going to be observed, right? And my dear children, by keeping our hand like this, we can take the fish like up. If you want to move it down, then we move it like this. So as you can see, from this position, I'm going to rotate. See, this is the place where I'm going to rotate it. See, when I'm going to apply a force from the middle, see, from this particular point, it's going to rotate up and down. So therefore, fulcrum is observed over here. This is the place where I'm going to apply the force, which is the effort. See? And at the end, here, we can observe the fish or else the load, right? So my dear children, this is the example, the fishing rod is the example for the third class levers. And the other thing is the broom, right? So these are the third class or the third types of levers. So now let's head on to the classroom and we'll identify the other contents in the lesson. So my dear children, as you can see, this is the setup which we can use to demonstrate the inclined plane. So this surface is behaving as an inclined plane. You know that this is the horizontal ground level, so it is showing an angle. That means this surface has an inclination to the horizontal ground, which is over here. So this surface is behaving as an inclined plane right now. So what I'm going to do is, at 3 different intervals, I'm going to find out the force needed to carry this weight upwards. In order to do that, I have with me, you know that this instrument is the, right, this is the Newton balance or else the spring balance. So there is a hook over here. Now let's see how much is the minimum force needed to lift this weight upward? Okay, now you can see that it's gradually moving up. Observe the force needed to lift it up. See, now at this moment the weight is moving slightly upward. Get the reading, a nearest reading. So exactly under the 4 Newton of force, right, it's moving upward, my dear children. 4 Newton of a force. See, when the Newton balance shows the value 4 Newton, it's moving upward gradually, right? So 4 Newton, you can observe the inclination very well, right? Now we are going to change the position. We'll change the position and once again we'll observe what will happen. Right, my dear children, now the second instance. Now you can see that the inclination is somewhat lesser than the previous case. Once again, so I'm going to apply certain amount of force by using the spring balance and I'm going to measure out the minimum force needed to lift the weight upward. Let's see. Right, now you can see that the weight is moving upward. Now the force which I have applied is nearly around 3.5 Newton, my dear children, nearly around 3.5. So you can see that the inclination is somewhat less right now. In the previous case, I had to apply 4 Newton of a force. But during the reduction of the inclination, the force needed to apply to take this wooden block upward is equal to 3.5 Newton. Now once again we'll observe by reducing the inclination even more, what will happen to the force that we need to apply in order to carry the wooden block upward. So my dear children, this is the third and the final step right now. So the inclination is even less. This is the one which has the least inclination out of the 3 instances. Once again I'm going to apply a certain force and I'm going to check how much is the force needed. So you can see that the object is moving upward. The reading is nearly 3 Newton, my dear children. It's nearly 3 Newton. Once again, let's see. See, now it's moving upward and the reading is nearly 3 Newton. So we can see that the reading has even reduced in the third instance up to 3 Newton. So 4, 3.5 and 3. So when reduction of the inclination, we can clearly observe the force that we need to apply is also going to reduce, and with ease we can carry the weight upward without any trouble. Okay, right. So let's head on to the classroom and we'll observe the other contents in the lesson then. So my dear children, here we are going to investigate the uses of these simple machines. So we have identified several simple machines, my dear children. So I have with me a wedge. You know that wedges are used to split off a certain object. Especially we use a wedge to split off a wooden block, right? Not like these ones, but heavy wooden blocks can be removed or can be splitted off by using a wedge. So here what we are going to do is we're going to apply the wedge onto a surface like this. Then by applying a certain force on the wedge, we can separate. As you can see here now, when I have inserted the wedge into the wooden block over here, see, now it has been separated. Now if I'm going to apply a greater force to here and if I'm going to hit it, right, and if I'm going to hit it, for sure this is going to separate into 2 parts. Okay, so this is the wedge. You know that wedge is having an inclined plane, see, and with ease it will get inserted into a block or else into a wooden block without any trouble. So this, by using a wedge, we can do our works very easily in our day-to-day life. So after that I have the screwdriver. So you know that we use these screwdrivers in order to remove or tighten a screw nail. So screw nail is like this, my dear children. See, this is the screw nail. So we have identified the properties of a screw nail. So you know that we can insert the particular type of a screwdriver onto this, and we can, you know, tight it down. Or else if you want, you can loose it up like this, or else tight it down. So you know that if you have a hammer and a normal iron nail, you have to hit it and it's very difficult. But however, if you have a screw nail, we can do the same work with ease, and the strength given out by the screw nail is even more greater than the normal iron nail, my dear children. So screw nail is a good example for the wheel and axle. And also, my dear children, here we can observe some amount of or some kind of a inclined plane. As you can see, the pattern of the screw nail is like in a spiral manner. So this is like an inclined plane. How can you say it? So to demonstrate that thing, I have a paper with me. So you know that this is an inclined plane. If I am going to place it like this, so you can see it very clearly that it is an inclined plane. See, what I am going to do is I am going to wrap this thing like this on this piece of paper, on this pen, my dear children. On this pen I am going to wrap this thing. So as you can see here, so now I have used that inclined plane, and my dear children, I wrapped it around a pen, as you can see here. So this is the pen that I have with me, which wrapped around with an inclined plane. So you can see the marking. So this marking is very identical to the one, the screw nail which is over here. See. So this is also a good example for the inclined plane. Now when I am going to remove it like this, see, this is an inclined plane. Right then. So for several day-to-day activities, we use several kinds of or different kinds of simple machines, my dear children. So these are like few examples. There are like heavy examples for simple machines. By using or by collection of these simple machines, even we can make somewhat complex machines like the bicycle. So within a bicycle, we can observe several simple machines, my dear children, right? So we use these simple machines to do our day-to-day usual activities, to ease our day-to-day activities, my dear children. So let's head on to the classroom once more and we'll observe the other contents in the lesson. So my dear children, here we are going to demonstrate the action of wheel and axle. So this is the axle, my dear children, which is been fixed to a certain clip so that I can rotate it very well. Okay, with ease I can rotate it like this. So as you can see here, this is a weight or else a load wrapped around this axle which is going to rotate when I am going to turn it. So this is the one which is going to behave as the axle over here. And when I am going to rotate it like this, you can see without any trouble, this weight is going to lift upward. See, this is going to lift upward without any trouble. That means with ease, we can rotate this handle which is over here, and by the rotation of the handle, I can lift the weight. See. So when I am going to loose it down, once again it goes down. See. So this is very simple, my dear children. So this is a very simple demonstration how to use the wheel and axle. right? So the wheel and axle is also being used to lift certain weights to a certain direction. I mean, like to upward, right? If you go to a construction site, you know that for the upper floors, the loads or the certain raw materials should be transported. In that case, my dear children, we use the help of wheel and axle sometimes. Then there are even more examples for the wheel and axle. The next one would be the steering wheel. You know that when you take the steering wheel of a vehicle, it has a certain axle which is going through the tube which is in the vehicle, and that tube is connected with the steering wheel. Okay, so the steering wheel has a certain large amount of, or I mean like the diameter or the radius of the steering wheel is somewhat higher than this one, or the axle which is going to rotate. So when I'm going to rotate the steering wheel, the axle connected to it is going to rotate, and because of that the wheels are going to turn, wheels of the vehicle are going to turn. So over there also the axle and the wheel can be observed. Then when you take screwdrivers, this particular part is going to behave as the axle, and this is the wheel. As you can see, the wheel has somewhat greater diameter than the axle, so that we can rotate it without any trouble. Okay, and also this is another type of a screwdriver, right? And also, my dear children, when you observe a key, you know that we use these keys in order to open or close our doors. So key, this part is somewhat smaller, however the head of the key is somewhat larger than the part that we are going to insert to the keyhole, right? As you can see here, this is the part that we need to insert it to the keyhole like this, and this is the, right, this part is the head of the key that we are going to hold it. Okay, so by holding the head like this, we insert it to the keyhole and we are going to rotate it. So this particular part which we are going to insert into the keyhole behaves as the axle, and this area and this area where we are going to touch it, this is the part which is going to behave as the wheel. So wheel and axle can be also observed when you are turning keys. Okay, so these are the examples for wheel and axle, my dear children. Okay, so wheel and axle is often used in day-to-day life to do our works easily, right? So let's head on to the classroom and we'll observe the other contents in the lesson. So my dear children, within this activity, we are going to check the action of these pulleys. Okay, so I have prepared a system. Over here you can observe this is the pulley which I have over here. So we are going to investigate the action of a pulley over here. So I have with me, like in the previous activity, the same object or the same weight which is wrapped with a small bit of a rope. Okay, this is a smooth rope, however there is a small bit of a frictional force. So now what I'm going to do is I'm going to measure the weight of the I'm going to measure the weight of the object like this. So it's around 3 Newton. It's around 3 Newton. See, check the reading, my dear children, carefully. It's around 3 Newton. So when I'm going to take it upward like this, I need to apply. So here now, when I'm going to take it from this kind of a point, this is the ground level. From this point, if I want to take it to a point like this, I need to apply 3 Newton of a force. 3 Newton of a force. Now let's see, by applying a pulley, whether we can reduce the force which we are going to apply or not. So I'm going to place it like this. So I have placed it like this. Now I'm going to insert the right. Now I have inserted the over here I have inserted the spring balance into the rope. Now gradually I'm going to take it upward. Let's see how much of a force is needed. So as you can see here, once again we can observe the same thing. Here in order to lift, see, in order to lift the weight upward, I need to apply 3 Newton of a force. So same force should be applied in order to lift the object upward. But however, my dear children, right? But however, my dear children, the benefit is, right now, as you can see, there is no benefit in using the pulley here, no. Even though I am using the pulley, I need to apply 3 Newton of a force at both the instances. If I am going to carry it like this, in that case also I need to apply 3 Newton. If I am going to use the pulley and drag it like this, that way also I need to apply 3 Newton of a force. The benefit is, my dear children, we can move it like from any kind of a place, right? So now from this kind of an angle, I can pull it upward. If the person is like at this kind of an angle, even though he can pull it upward without any trouble. If the person is at the ground level, in that case also, see, without any trouble, right, we can pull it up. So no matter the place or no matter the place where the person is going to stand, he can use this pulley in order to drag this weight upward without any trouble. So that's the main benefit that we can observe within a pulley. Okay. So my dear children, now remember, by using a pulley, we won't be able to reduce the force that we are going to apply to lift the object. But however, it becomes more convenient for us. That means we can use it from any of the places to lift this thing upward. That's why we are saying that this particular pulley can use it, or we can use this particular pulley to do our day-to-day work quite easily. Okay, by using any kind of a place or by sitting on any kind of a place, we can lift this thing without any trouble. Right then, so this is the use of the pulley, my dear children. So let's head on to the classroom and we'll observe the other contents in the lesson. Right, my dear children, now here we are going to study about a system of pulleys. Now in a system of pulleys, there can be several pulleys, my dear children. We use these several pulleys to make our work easy. So there can be some pulleys which are moving and there are some pulleys which are still, right? So here I have prepared a system of pulleys, my dear children. So this is the weight or the load. Now I'm going to use like this. I'm going to insert the first pulley like this. Then I need to insert this wire or the thread through the pulley, right? So this pulley is the moving pulley. Okay, my dear children, this is the moving pulley, right? And this is the still one. Right, now there are two pulleys. When I'm going to pull it from here, you can see the pulley over here gradually comes up by lifting the weight which is over here. So when I'm going to turn it down, see, once again it goes down. So by using several pulleys, we can even, we can change the direction, right? Now we can change the direction of the force which is getting applied to move the weight which is in here. Okay, so earlier it was Now in the earlier time it was, now we have used only one particular pulley. Now only from a certain direction we have to apply the force, but in here we can change the direction 100% to a different location, and by that way we can lift the force, we lift the object without any trouble like this. So in here one pulley is moving and the other is in the still position like this. So these system of pulleys are also used to make our work easy, my dear children, right? Okay then, so these are the examples. So these are the places where we can use the, right, or this is a demonstration where we can use the system of pulleys to make our work easy. Right then, so let's head on to the classroom once again and we'll do the other things related to the lesson part.